So we're going to kind of look at something right here regarding reflections. And guys, basically this is, again, a pretty easy section. A lot of just counting and moving units again. And I guess the essential question we're looking at is how do you reflect a figure in a coordinate plane? So in order to do that, guys, we're going to say we need to be able to perform reflections. We're going to perform what's called a glide reflection. That'll be kind of new for you today. We're going to identify what a line of symmetry is. What do you guys think a line of symmetry is, by the way?
A line that
Something that cuts one thing in half.
So it kind of cuts it in half, so it's the same both sides, exactly. And then we're going to look at a couple of real-life problems involving reflections. But pretty short section today. Should be pretty easy, I think. So let's hit the vocab here hard. Make sure we know what our terms are when we're discussing everything. Guys, a reflection is basically a transformation. Again, transformation is just a fancy word for saying some type of a movement that uses a line like a mirror to reflect a figure. So as an example, maybe I have a shape that looks like, oh, I don't know, maybe like this. And then I have one that looks like this. Now, give me a second to fix that. Is that a reflection right there? Is that a reflection, guys? Or is that a translation right now? Translation. But now, how about now?
Yeah.
How about now? Okay, they're not exactly alike, but I'll do my best here for you. Try and make them look the same. Yeah, it's kind of a reflection. Basically, can you see how this would get flipped over on this? In other words, if I had a line right here, if I had a line right here in the middle, if I kind of folded on that line, wouldn't this triangle fall over on top of the right triangle there on the right side? Wouldn't the one on the left fall on the one on the right? Okay, so you get the idea of what a reflection is there? Okay? Then, line of reflection. Okay, so I put this line right in here. So this line right here is called your what? Line of reflection. Basically, as I'm looking in the mirror every morning, what line is or what's the line of reflection for you? Mirror is, isn't it? Okay, mirror is, okay? If I move back away from the mirror, what's it appears happening in the mirror? Looks like you're backing away. As I keep pushing my hand towards the mirror, what appears to be happening? Looks like it's getting closer to you, right?
You ever thought of like a mirror being like a second world or something?
Say that again.
Like a second world?
tree.
Like a
It
mirror
never
being a
stops
second
growing.
world? You ever thought about that?
It never stops growing as hard as it can.
You ever see little kids with mirrors? Like, I mean like little kids, like less than a year, and they're crawling around and looking in the mirror, and they're like, see them for the first time, they're like, whoa.
Or Brandon's
Pretty cool.
fighting chickens. They freak
Okay.
out.
It's interesting. So yeah, you're right there. So a line is going to be, it's going to be a line that acts like a mirror for the reflection. So I'm just going to put an arrow right up here and say in that drawing up there, that is your line of reflection. That's your line of reflection right there. Okay. Volunteer to read glide reflection for me. Go, Hannah.
A transformation involving a translation followed by a reflection.
So we already know what a translation is. You're going to slide something first. You're going to slide it first and then reflect it. So what I'm going to do is I'm just going to put some, terminology up here. Basically, you're going to take a figure and slide it first and then flip it. Slide it and flip it. That's all you're really doing there. Okay, and I'll show you some examples of a glide reflection here in a second. Guys, line symmetry, don't confuse these two right here. Notice these two terms that we're going to look at next. Pretty close to each other, aren't they?
Yeah.
Pretty close to each other. Line symmetry says a figure in the plane has line symmetry when the figure can be mapped onto itself by a reflection line. Okay, so here's an example. Here's an example. Let me do this. I'm going to put a nice rectangle up here. There's your rectangle right there. Okay. Now, they say rectangles have line reflection because if I would draw a line of reflection right here, I should say line symmetry. If I would plot this point right here and fold along this line, where would this point fall? Where would this point fall if I folded right along that line? On the other side. So the bottom right, wouldn't it? Now, think about this, guys. This point right down here falls over here. But if I folded this, where would this point fall? back to the what?
The other one.
Okay. So what they're really saying is you're going to move points around. If this point was A and this point was B, if you reflect A over, A is going to fall where B was, B would fall where A was. We say stuff has line symmetry if you reflect it in the middle and you get the same shape back. Does that make sense to you? Okay, so basically what they're saying is figures have line symmetry. If you can draw what's called a line of symmetry through the figure that cuts a figure into two congruent figures. Here's a question for you. Here's a shape. Here's a shape right here. Here's my circle. Does a circle have line symmetry? Meaning, can you cut it into two equal halves? You can. All right, you can. The left half would fold over onto the right half, and the right half would fold over onto the left half. Or the top half could fold down to the bottom half, and the bottom half could map to the top half. Okay, can you guys think of other shapes that have line symmetry? A square does. How about a hexagon? Would a hexagon, a regular hexagon? How about think of your stop signs down there? Regular octagon. Would the left half and the right half fold on top of each other, fold side to side? Yeah. Okay. Can you think of a shape that doesn't have line symmetry? Some triangles will if all the sides are equal, but if the sides are different, like these up here, does this have line symmetry? Will this fold over? It won't. Okay, so they have to be a regular polygon, meaning all sides are the same. Okay. So guys, reflection, line of reflection. The thing I want you to understand, guys, line of reflection and line of symmetry kind of mean the same thing. Okay. The one that's going to be very new for you today is called a glide reflection, and I think you'll understand that when we get done. Okay. Guys, in order to be successful in this section, we need to recall some graphical situations. We're going to look at some situations where we recall some lines, because in the coordinate plane we're going to reflect a lot of figures. So you need to understand what type of line you're reflecting over. So I wanted to recall this. Maybe draw a coordinate plane quickly in each one of these, like this. Okay, and I'm going to put some lines in here. So go ahead and do that first. Okay. All right. My question to you is this. Do you guys remember what type of line you would get if you were graphing x equals some number? In other words, like x equals 4. Remember what the graph looked like, what type of line that was? Let me explain it to you this way. If I said something like x equals 4 right here, x equals some number, 4 in this case. What you do is go on the x-axis to what value? 4. And you would draw a line that crosses the x-axis at 4. So would that be vertical or horizontal? Vertical. So it would look like this. Okay, anytime you have x equals some number, what kind of line do you have?
Vertical.
Vertical. So what's that make y equals some number look like?
Horizontal.
That graph will be horizontal. So maybe I have something like that. And I don't know where it's at. It's somewhere up and down the y-axis. If it was y equals 6, you would go up 6 on the y-axis and draw what kind of a line? Draw horizontal. Okay. Now, the ones that are going to be kind of tricky today is this line of reflection where y is equal to x and y is equal to negative 1x. Do you guys agree that x is the same as 1x plus 0?
Yeah.
Okay, 1x plus 0. So what would the y-intercept be in that case? And what would the slope be? 1. So it's going to be a line that looks just like this. This is a line of reflection we're going to use a lot. It's going to be a line that passes through the origin and has a slope of 1. Okay? So we're going to be reflecting about that line today. What do you think y equals negative x is going to look like? Same, but it's going to be not increasing, but decreasing through the origin with a slope of negative 1. Okay, so these lines are crucial to what we're going to be doing today in terms of reflecting stuff. So the thing you need to remember, if it's x equals some number, what kind of line of reflection are we going to have? Vertical. If we have y equals some number right here, what kind of line of reflection are we going to have? Horizontal. If my line of reflection is y equals x, It's increasing, slope of 1 through the origin. And if my line of reflection is going to be y equals negative x today, it's going to be decreasing with a slope of negative 1 through the origin. Okay? Do you have those 4 graphed quickly or sketched out to refer to? Very important part right there today. Very important part. Okay, so let's look at some examples. Let's run with this today. Everybody have what they need on page 1? Okay. Page 2. Guys, reflecting in a vertical and a horizontal line. So this is kind of what we just talked about. We need to be able to reflect figures. So first we need to do this, guys. It says graph triangle ABC with vertices A at what value, guys? Where's your A value in your notes? 1, 3. Where's the B value? And where's C at? 2, 1. So let's do this. You guys help me graph this. So give me a second here. 1, 3. How do I get to A, guys?
To the right one.
Right 1 up 3. So right 1, 1, 2, 3. Does that look right to you guys? Right there?
Yeah.
And then where's B at?
Right 5 up 2.
Right 5 up 2. And then finally, where's C?
Right 2 up 1.
Right 2 up 1. So this is triangle. I'll do my best to sketch it here. I'll try. You guys okay with that? Pretty close, isn't it? Let me draw my points on top now. So what was the first one? A was 1, 3, so that's right here. Where's your B value at? 5, 2. Okay, have I labeled that correctly? Okay. So we have the original figure there. Now guys, it says take that triangle right there and reflect it over which line first, guys? What are we reflecting this over first?
Vertical.
It's going to be a vertical line, x equal negative 1. So my line of reflection is going to look a lot like this. My line of reflection is going to look a lot like this. First of all, on the x-axis, where do you need to go to?
Left 1.
Yep. Get on the x-axis and go to which value? Which value am I going to? Negative 1. And now what kind of a line through negative 1 on the x-axis? You guys told me already.
Vertical.
So then you're going to draw a vertical line. All right? Draw a vertical line. Okay, so let me do that. Let me do that. Here it is. Here it is. X negative 1 right here, right? Right? Isn't that just 1 unit to the left? So here comes my line of reflection right here, kids.
Oh, that makes sense. Okay.
Okay, does that make sense to you guys? Right there? So now it says, hey, I want you to take this figure that's on the right of your line of reflection and fold it over. And here's how this simply works. You're simply counting units. Guys, on this horizontal right here, look at A. How many units to the right of my line of reflection is point A? 2. So its image should fall how many units to the left?
2.
2. Okay, so when I label this over here, 1, 2 to the left right here, 2 to the left of your line of reflection. It's not the y-axis, it's the line of reflection you drew in there. What are you going to call that point?
A prime.
A prime.
Oh, I got it.
Okay, by the way, what's that coordinate of A prime now, guys?
Negative 3.
Negative 3, comma 3, right? All right, explain to me where to put B prime. In fact, why don't you guys tell me the coordinate of B prime when you're done.
Negative 7, 2.
Negative 7, 2. Let's see if we agree. Left 7, up 2. This is B prime. Let me just check this, guys. B prime, watch this right here. I'm going to count. B prime is 1, 2, 3, 4, 5, 6 units from the line of reflection or line of symmetry. So that means B should be 6 units to the right of it, right? So let me count. 1, 2, 3, 4, 5. It is 6 units. Got in the right spot, right? Then how about your C, guys? How many units to the right of the line of symmetry is that?
4.
Looks like 1, 2, I'm going 3. So how far to the left do I need to go?
Where's that at? Trace. 5.
Call this point C prime. What's that coordinate? What's the coordinate of C prime? Negative 4, 1. Yep. So I'm going to draw my triangle. Okay, and I didn't want that to be dotted like that, so I'll fix that. And there it is, guys. There it is. Is that a rigid motion? Did we change size of it at all? No, not at all. Okay, not at all. So there's that. So what I want you guys to try and do right now is this. I want you to do the same exact thing. Go ahead and plot your original triangle first. Plot your original triangle again, down in the second graph. So help me with those points again. What were they?
3, 1.
3, 1?
1, 3. 1, 3.
1, 3?
Messed up. No.
Oh, so get rid of the 3, 1. 1, 3. Okay. 5, 2.
Oh, yeah. 5, 2.
And 2, 1. All right, so I'll take a shot at drawing this. Guys, what's your line of reflection this time?
3 horizontal.
Y equals 3. So on the y-axis, jump up to what value?
3.
What value are you jumping up to? 3. And what kind of line are you going to draw there? Share your notes from the top right there, or top left over there, with your name on them. Okay. Now I kind of missed on this point right here. But guys, in this reflection right here, if I called this point, well, the way it was labeled, this was A, this was B, and this was C. What's going to happen to A? A is actually where, guys? It's on the line of reflection. So A prime is actually going to stay where? It's going to stay right there on the line of reflection, isn't it? Okay, so would you guys agree with that right there, that that's going to stay in the same spot? Okay, so somebody describe to me where C is going to fall.
2 units up.
2 units up from where, Gavin?
The line. Like, yeah, the line.
So line of reflection. So you're saying C is 2 units below, so I want to count 2 units above, and we're going to label this point C prime, and then finally B prime, folks.
1 above.
1 above. All right, so again, where was A going to stay? On the line. That's our line of reflection right there. Okay. Quick question. When I'm done with this, is this a rigid motion again? Hannah, you said yes?
Yes.
Why?
It doesn't change in size.
Doesn't change in size. Very good. Whoops. My artistic abilities are saved once again by the Mimeo. First mistake all year, exactly. Thanks, Ryan. Appreciate that. Okay. At least the ones I can remember. I forget most of them all the time. Have a good day, guys.
Thank you.
All right. Are we okay with, first of all, reflections in vertical and horizontal lines? So now what we need to take a peek at is, what does this look like? What does this look like when we start reflecting stuff over lines y equals x, y equals negative x? And again, things are pretty simple. Now guys, vertical and horizontal lines, you're always counting left and right and up and down. Everybody agree with that? You're counting left and right and up and down all the time. Okay? But now think about your lines of reflections. Y equals x, y equals negative x. My question is, are you in a situation where we're talking horizontal and vertical lines anymore, or are we talking about diagonals? Diagonals. So instead of counting left and right and up and down, how do you think we're going to count now when we start reflecting over these lines? We're going to count left and right up and down, or we're going to count diagonally. Good. Okay? So let's do this quickly, guys. I'm going to plot these points. I want to plot these points. It says, graph your line AB with endpoints 3, -1, and 3, 2. And then it says reflect this. I can just do it this way. Reflect this in the line y is equal to what here, kiddos? X. Okay, so let's do this. Now, guys, your line y equals x, we've got to be very careful about it. And I'm going to show you how to graph that line y equals x as easy as possible. So let's do this quickly. Let's get our 2 points in our line segment drawn first. What are the 2 points we're dealing with in example number 2? A is what coordinate, kiddos? 3, -1. So right 3 and down 1. Whoops. Right 3 and down 1. How about your next one? 3 and 2. Right 3, up 2. All right, kids, watch this right here. We're going to call this point A. We're going to call this point B. And I want you guys to go ahead and draw your segment in there. Okay, just like that. Just like that. Now, I think it would be pretty good of me to probably hand you a straight edge. So why don't you guys take a straight edge for these diagonals and then move them on. You'll need that for this. You know, on the assignment that I handed out, not so much. I think they put that right in there for you. Jared, were you able to answer the question that Mr. Lowers asked you?
Yeah,
Or did you tell him you just got here?
I said that we were just reflecting on the horizontal line.
Perfect. You're a good man, Jared. Okay, let me know when you guys have when you have a straight edge here. You got to fill in the rest of that. Okay, here's what I want you to do. Everybody have a straight edge, kiddos?
Yeah.
Okay, no? Yes, no? Did you guys get rid of that corner there?
Straight line.
No, I'll get you one.
Back there. Gosh, the batteries on these phones.
Yeah. Okay, guys, what I think would be very good for you to do is to go from corner to corner. This is pretty square right here. If on your graph right here, the line y equals x is basically going to be a line from this bottom point down here through the origin up to this point right here. So if I were you, I would go ahead and I would draw this line in here for a line of reflection like so. So here it comes. Here's my line of reflection right there. Okay, line of reflection is right there. Guys okay with that? Okay. This here is your line of reflection that we're going to reflect about right here, the dotted line, which is right there now. Okay. All right, here's the deal. Guys, if A is on the bottom half here of this line y is equal to x, where do you want A prime to fall? Wouldn't it fall on the top half up here somewhere? And B is also on the bottom of this right here. Wouldn't that B prime fall up here somewhere? Okay, so I'm going to move my B a bit here, the way I've labeled this. I don't like where I've labeled B, so I'm going to move that. Pretty cool. I can just move that, eh? All right, hey, check it out, guys. B prime, here it is. Guys, see where my line of reflection is through this diagonal or through this square right here for B? B is right here, so wouldn't that make sense that B prime would fall the same distance or same distance diagonally away? So doesn't that look like half of a box right here? Half a box diagonally to the B. Wouldn't half of a box the other direction in that box be the way to get to B prime? Yeah. Okay, so I'm going to go ahead and say, hey, B prime has to fall right there at that coordinate. And what is that coordinate, guys?
2, 3.
Now I want to show you something about reflections y equals x. This is pretty cool, the way this works. What was this coordinate for B, guys? It was right 3 and up what?
2.
Where did B prime fall?
Right 2 up 3.
Notice anything about that?
They're back.
It just reversed. Okay? So let's see if there's anything to this at all. Guys, if A is right here at, what's this coordinate again?
3, -1.
Based on what happened with B, any guesses on A, where A prime might fall?
Negative 3, 1.
-3, 1. Not quite.
Oh.
-1, 3. Let's check and see what happens here. Let's check. Nope, you're fine. You're fine. You're fine. Watch this right here. Guys, do you agree going from here, going diagonally? Here's one diagonal, two diagonals to get to the line right there. Wouldn't this be then two diagonals this way? And wouldn't A prime appear to fall right about there? What's that coordinate then?
-1, 3.
Oh my gosh. So I have a question to you. Anytime we're flipping about the line y equals x, what do you just do with the coordinates to get the reflection point? Yeah. So I'm going to make a note right here. I'm going to make a note right here. The x's and the y's simply switch. Think about it. They say y equals what? Which means x equals y. You're basically just saying, let's switch the x's and y's. So I'm going to make a note right down here, and I think it would be very important for you to get this, all right? A lot of stuff going on here, and I really like this. This is cool. Whenever when you reflect over the line y equals x, I'm going to give you a hypothetical situation. If the original point is A comma B, whatever those numbers are, what's the image point going to be then? B comma A. Anytime. And it only works for y equals what, guys? X. So if you ever reflect over the line y equals x, really all you're doing is switching the x and y values around. Okay? So if the original point is some number A comma some number B, a reflection over y equals x would switch that around to b comma a. Just like right up here. 3 comma 2 became what up here, guys? 2 comma 3. 3 negative 1 became? Negative 1, 3. And I think the one thing I really forgot to do up here, make sure you connect your line from A prime to B prime. Let me do that quickly. Draw your line A prime to B prime right there. That's how they reflect. That's how they reflect. Okay? Does that make sense? Okay, so let's see what happens. Let's see what happens then when we reflect over the line y equals negative x. I want to take my time here. I want to make sure everybody has down what you have or what you need for example 2. There's a lot of stuff going on in that example right there. Are we cool with that? Everybody okay with that? All right, well, let's look at the next example on the 3rd page. 3rd page. Ooh, that's pretty. Mine was broken after the Twins lost last night late. Okay, kiddos, here we go. Got beat out a buzzer beater, didn't they?
Yeah.
Insane. Insane game.
I didn't watch it.
That was good.
That was stupid.
One for the... Wow.
I would never rather see UNC win.
Hey, all I know is that the Hawkeyes are tied for 1st place in the Big Ten now. All right? And it's going to be a rough year next year. I think all Iowa teams are going to have a rough year next year. All right, kiddos, let's get through this one. Again, same points, plot A and B. But this time, instead of graphing over y equals x, we want to notice what happens when we graph over y equals negative x. So let's look at this. What are my 2 points that I'm plotting again?
3.
Okay, so write 3 down 1, right, Britt? And what's the other one? 3, 2, right? 3 up 2. Okay, so there's A. I'll put that here. I'll put B here. Go ahead and get your line segment produced in there. So I'm going to put my line segment right there. There's my blue line segment. Now this time, where are you going to graph your line of symmetry this time, guys? Instead of bottom left to top right, we're graphing over y equals negative x. So where's that line of reflection going to go? Through the origin with what kind of a slope? Negative 1. So basically top left corner to bottom right corner. So go ahead and get your line of symmetry graph there, guys, or your line of reflection, if you will. I think I've got this. All right, so my line of reflection, there it is. Let's change color with that. Ooh, that's pretty. I like that. Okay, so the same game, guys. Same game. If I want to reflect over some points here, first of all, I'm going to write the coordinates down over here by this, and we'll see if we can notice anything. You guys agree with my coordinates right there?
Yeah.
So check this out. If I draw a line from A diagonally, how many diagonal units is A to the green line? Isn't it 1 unit there? So wouldn't A prime fall right here? Guys agree with my A prime and its location? Everybody agree with the A prime location?
Yeah.
Okay. Then, check on B for me. Check on B. I'm going to draw some diagonals here. I'm going to go diagonally this way to cross that line. So I'm just going to count my boxes diagonally. There's 1 diagonal, 2. Looks like how many diagonals to get there, guys? 2 and a what? Here's 1 diagonal all the way through that box. 2 diagonals through that box. Do I go all the way through this box or halfway through it?
Half.
So it looks like 2.5 diagonals to get from B to my line of reflection, right? Which would mean I want to go 2.5 to the other side. So here's half. Here's 1.5. Here's 2.5. So do you guys agree that B prime must fall right here? Okay, so there's a segment in terms of a reflection from here to here. Okay. Help me out with the coordinates here, guys. What's the coordinate of A prime?
1.
What's the coordinate for B prime?
Negative 2, 3.
-2, comma, positive 3 or negative 3, kiddos?
Negative.
Notice the pattern from A to A prime, B to B prime, and how the coordinates are related. What's true about the 3 and the 2, first of all, up here? They're positive. But how about the order of 3 and 2 down here? They got switched. Then what happens to the sign? You switch them. So here's the deal. Same thing as in y equals x. Y equals x just switches, but it keeps the sign the same. When you graph about y equals the opposite of x or negative x, you switch the order of the lines, but what happens to the values inside the parentheses? What do you do to the signs of those values after you've switched order? Flip them or swap them, okay? So let's make a rule for this. Here's a question. Let's suppose 16 comma 22 is out here. Where would 16 comma 22 reflect to in this example? Negative 22 comma. You got it. So let's make a rule for this. Let's make a rule for this. Ooh, I think I can squeeze that in here. I'm going to put the rule over here. Is that okay, guys? Shoot. Okay, rule. Okay. I want to see how I wrote the last rule. When you reflect over, okay, I'm going to write it this way. Here it is. When you reflect when you reflect over the line y equal negative x, if your original point is A comma B, where does your image land then, guys? Where would the image land? What do you do with the A and the B? Switch them. So it'd be B comma A, but not positive B, or not B, but, okay, so the opposite of B comma opposite of A. So here's a question. Let's suppose the point negative 2 comma 12 is a point. You reflect over the line y equals negative x. Where does the image fall at? Where would the image fall at for this point right here? Negative 12 comma 2. What if you were reflecting that over y and y equals x?
Oh, give me a second.
Okay.
12.
Okay, understand the difference between the two? Negative x. If you can think negative x, you switch the order and then swap the signs. Switch the order and swap the signs. Y equals x just means switch the order. Okay? Can we handle that?
Yeah.
Okay. Let's talk about glide reflection quickly and then some lines of symmetry and we'll be done here this morning, okay? You guys feeling pretty good about this so far?
Yeah.
Any questions at all? Okay, let's look at these last two examples here. Glide reflection, guys, we had said in the terms that a glide reflection is to translate a figure first and then reflect it. So it's like saying slide and flip, slide and flip. It's kind of like a NASCAR. You lock up the brakes, your car might start sliding sideways, and then if you get sideways like that, you might start flipping. Okay, so on NASCAR, you might say, oh, there goes Dale Earnhardt Jr. on a glide reflection. Never mind, not good. I get it. I'll keep my day job, all right? Probably Danica Patrick on a glide reflection, though. She crashes a lot. Did you know what Danica, do you know what Danica stands for? Does anybody notice I crash a lot?
That was actually.
That's pretty good. Come on, give me some. All right, hey, help me graph this triangle ABC. You guys do that quickly on your paper. We're going to say graph triangle ABC with vertices 3, 2, 6, 3, and 7, 1. So go ahead and graph those. 3, 2. I hope I gave enough room to do this. 6, 3, right 6, up 3 is my B value, and C is at 7, 1. All right, so I'm going to sketch my triangle in there freehanded. Save some time. Okay, so this is triangle ABC. You guys agree with what I have here?
Yup.
Okay, I'm going to tell you how to glide this thing. I'm going to tell you what the glide is, and then what to reflect over. Okay, so here's the translation. Translation. I want you to translate x comma y such that it becomes x minus 2 and then y plus 1. And then after that, I'm going to say reflect this over let's go y equals negative 1. Okay. So I've given you the translation rule up there. All points in the original figure are going to translate into x minus 2 and y plus 1. So we'll figure out where that goes first. And then after that translation is made, then we're going to flip it over the line y equals negative 1. All right, so let's, you guys help me with this. Guys, talk to me about this translation. How is this going to slide, first of all? What's the x minus 2 represent? What direction? Left 2 and then up 1. So do that with me quickly. Left 2, up 1. Let's move everything left 2, up 1. Let's do that quickly. So here's left 2 and up 1. So this is my A prime. Left 2, up 1 would be B prime here. Whoops. Wait a minute. I think I screwed up the A prime, didn't I? What did we say, left 2 and up 1, guys?
Yeah. You went up 2.
I think I went up 2, didn't I? Left 2, up 1. That should be right here.
Yeah.
1 comma 3, that's better. B prime, left 2, up 1. C prime, left 2, up 1. C prime falls right here, right? Okay, so let's draw that translation part first. Go ahead and do this. All right. Now, that's the gliding part of it. That part is the glide. Glide is like slide, right? It would have been nice if they would have called it a slide reflection, because I said, hey, use the word slide for translation, right? But they didn't. And just like a lot of the things in America, that doesn't make sense either. Now, what line are we reflecting over?
The Y.
Y equals -1. What type of line is that going to be for reflection? Horizontal. Okay, so I'm going to come down here. On the y-axis, I'm going to jump down to -1. Here's that. And my line of reflection will look as follows. There. And then basically it's a matter of counting. So let's look at this now. And I want you to be careful on the labeling of this. Guys, my A right here, how many units above the line of reflection is A prime right now? 4 units. So where is A double prime going to fall now for the reflection part?
Down.
So down 1, 2, 3, 4. So if I had to say, hey, what's the coordinate of A double prime now? And I say A double prime because isn't that the second transformation? First one was to slide it. The second transformation then was to reflect it. Okay. So talk to me about B double prime. Where's that going to land? What coordinate?
4, -6.
4, -6. So is that 5 units below the line of reflection? So there's B double prime. Okay. And then it looks like C is 1, 2, 3 units above the line of reflection. I should say C prime is 3 units above the line of reflection. Therefore, its image would fall
5, -4.
5, -4. I like it. Okay. And then when you're all done, there's your glide transformation. That's where everything ends up. Okay? That's where everything ends up. Think you can handle that?
Yeah.
All right. So the last part that I need to discuss with you guys then is going to be identifying lines of symmetry. Guys, I need to ask you to label a couple of things right here. On this pentagon right here, put some tick marks through each side to indicate that they're all equal. Guys, is there any way you can put a line through this so that this would be have line symmetry, meaning that the top half is the same as the bottom half, or bottom half would fold on top of the top half, left by falling right? Where can I draw one at?
At the corner. No, you stupid.
Like that?
In the middle.
I'm not talking about that.
Would that work?
What are you talking about?
If it was in the middle,
Yeah,
it's
we're
straight.
still in the
Horizontal.
Okay, well, assume it's, okay, hang on. Better?
That's what I'm talking about. So
Better?
you just put words in my
And then
mouth.
you do it this way, the same way.
Would a diagonal one work here?
No.
Yeah.
I tried it. It won't work.
Yes, it will.
Fold your paper.
So it's a rectangle, right?
Okay.
It's a rectangle, right? Is this a rectangle?
You can't do
It's
it.
even.
No.
I take the opposite corners right here. Do they fall on
Say
top?
what you did.
Look, does it work or not?
No.
So is diagonal gonna work there?
I didn't say that. I said like this.
I'm gonna tell you this right now. Diagonals will only work if the figure has equal sides. So if it was a square, it would work. But in the rectangles, not gonna work. Now what I'm getting at here with this regular pentagon, when all sides are the same, I'm gonna sketch these in here as best I can. So just do the best with me here.
Yeah, you can do it all the
One would work here. One would also work this way. If it's a regular polygon, if you have a 5-sided pentagon and all sides are the same, how many lines of symmetry are you gonna have?
5.
If you have a hexagon, hexagon's an interesting one.
How many?
6. Octagon would have 8. This is what you would have right here. Okay, and then what you formed here is like the Chrysler symbol. Okay, you get what I'm doing there?
Yeah.
Okay. How about that heart? Is there any line of symmetry to that heart?
One. Down.
Where? Like so?
No.
Like an arrow through my heart, the baseball game yesterday?
In
Or
the
this way?
middle.
Just like that? Any lines of symmetry for this figure?
No.
No. So there's times you may have figures that don't have any. Okay? My main concern today is this. Can you graph over the four types of lines we talked about? Reflect over the four types of lines we talked about. Do you understand how y equal x and y equal negative x? Do you understand how the coordinates are related when you're mapping from a pre-image to an image? You understand that relationship? Okay, get that worksheet done, turned in today. If you didn't turn in first hour, I sent out 11.2, which will be due Thursday. I'll tell you tomorrow we're going to have a short review. Thursday, guys, we're looking at a short quiz over the first two sections of Chapter 11. Okay? So short quiz coming on Thursday. Okay? Questions at all? Okay, you guys have a great day, all right?